Hello everyone, this is a video about how to work with data that's not in the native format for lsdtopotools. In this example, I'm going to play a bit with USGS data and also with some Scottish LiDAR data. So for all lsdtopotools analyses in Google Colab, you need to do three things first. And I've done this already in this environment because it takes about a minute and a half or 2 minutes. So first you install this package called lsdtopotools. You then install Conda Colab, and finally you install lsdtopotools with these commands. This analysis is based on a notebook that you can find in our GitHub page. So if you go into lsdtopotools and lsdtt notebooks, there is a, so there's actually two notebooks. One is this about debugging gdal and proj. This came about because the old notebook wasn't working, and I'll talk to you a little bit about that. And then the other notebook is this, if you go into basic examples and look at getting USGS data into lsdtopotools, what I'm about to talk about is based also on that example. Okay, so I've got all these things installed. So the first thing is that if you want to manipulate rasters, the best way is probably gdal. And those of you who use GIS software, many of you probably have used QGIS. When you manipulate rasters in QGIS, it's actually calling gdal. So we're skipping the middle software and just going straight to the gdal. The issue is that in Colab, when you install gdal, it needs to communicate with this other package called proj, which has all the projections in it. And frequently when you install gdal, Colab doesn't know where to find proj. So I'm going to show you how to tell it where to find proj. So what are we going to do? So I'm going to go up. I'll do this all live, but I've done this before. So once we've installed gdal, we need to find where a file called proj.db is. So we use this command. Again, it's in this other notebook, but it's find and then proj.db and some other stuff that makes sure it all works. So I do that, and it will give me a few places where this database is. So there's actually several places where the database is. We need to tell Colab where it is. So we use a little bit of code that calls the operating system in Colab. We need to set an environment variable called projlib. And basically, when you do this yourself, you should have these same sorts of things. But in my case, I used this one. So you just use the directory path with the final backslash to get the database working. If you don't do that, you will get errors that say things like could not open proj library. And if you do that, you're going to get all sorts of nasty errors when you try to switch DEM formats around. Okay, so I've set that library, and I should be able to work through this example without more problems. So what's the next bit? The next bit is downloading a bit of data. So what I'm going to do, I'm going to go to opentopography.org. And just starting from the beginning, if I go anywhere, so if I click on the home page of OpenTopography, I can click on the data page, and I go into data catalog. And there's all sorts of data here. So you've got all this LiDAR data, you've got global DEMs. In this case, I'm going to use the USGS DEM. So what I'm about to do will pretty much work for anywhere, but I'm using it with USGS data for this example. So what I want, I'm going to get some 10-meter data. So I use USGS 10-meter data, and I will zoom in somewhere. I don't know, let's do something fun. Near Olympic National Park, near Seattle. Let's just click. I'm just going to click the middle of it here. Okay, and I want to get some of this data. So I pick the region, I say, yes, 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 this is all good. I'm going to do test, and I'm not even going to sign in. I'm just going to, oh, okay, well, I'll do my own email. Okay, so this will take a minute or so. What will happen once this ends up finding the DEM, it will give you a data set, but that data set won't be in a raster format. It's actually going to be zipped, and it will also be tarred. So a tar is just another kind of form of compression. So once that appears, so you'll see rasters, zipped, and tarred. So I click on that, and it will download somewhere. So here it is downloading, and once it finishes downloading, depending on what browser you have, probably will end up in your downloads. So I'm just going to go over here to my downloads, and if I wait, here's the download here. The download is, click on that. Here's the download here. So how do I get that into Colab? Well, I just go into my notebook, and in Colab, in this left column, there's a file thing. And so I just pull this thing across. When you put files into a Colab session, it's only visible for that particular session. So it doesn't have memory. If you want to keep files around, you're going to need to put them into your Google Drive. One disadvantage of Colab is it takes a really long time to upload stuff to Colab. So we'll just wait around. And actually, while we're waiting, what I'm going to do, I'll show you what command you need to use to turn this tar and gzipped file into just an actual file that you can use. So we use a little command called tar. And so in any Colab session, I've done this a few times before, but if you have an exclamation point at the beginning of your line, you access a Linux system that sits underneath your Colab session. So in this case, when I do exclamation point tar, I'm calling this little Linux program called tar, which is useful for unzipping things. If you're in Windows, you might notice that tar is much, much, much faster than any unzipping programs in Windows. So actually using Linux to unzip big files is quite convenient. Okay, so that is nearly finished uploading. Looks like that's done. Let's just make sure it's done. Okay, that file seems to be there, so I've refreshed the file system. There it is. So now I'm going to do this tar. These three flags are just the things that say unzip it in the way I want. You would always use this -xzf if you use tar. So I'm going to do that. Now, if I refresh this, I've now got a TIFF file. So that is the actual raster data. But TIFF is not the same format that is used by lsdtopotools. We want something called an nvbil file. So we're going to use gdal, a gdal program called gdal warp. So gdal has a Python thing, which you need to write a bunch of Python code, but it also has these command line programs, which allow you to do all sorts of different stuff. And it's for me, it's much faster than using the Python, so I use these command line tools. So what is in this gdal warp command? So one, you need to have OF, that's the output format, and NV. So NV is the files that lsdtopotools use. Here is the resampling resolution with the flag TR, and I'm doing it 10 meters by 10 meters each pixel. You must have the resampling method. The default is nearest neighbor. If you do nearest neighbor, you're going to get this blocky looking DEM with all sorts of artifacts in it. So you need to use either cubic or bilinear. Either one are pretty much as good. Cubic's a little bit slower and a little bit better. You need to tell it what raster you're warping to a new projection, and then you just need to tell it what the DEM you're using is. So in this case, I'm just going to call it my DEM. Finally, you need to tell it what projection you're using. So lsdtopotools uses UTM as its native projection. Your raster needs to be in UTM. So you want to find the UTM zone where your raster is. So where is your raster? There is a UTM zone. Well, if you just Google or look up the UTM zones, so there's one page called DMAP. I'm about to show you this page. So you just look up where you've got your area, and you then look up the zone. So the zone is down here. We are in the state of Washington. This happens to be zone 10. So I need zone 10. So I'm just going to change this to zone 10, and I run this conversion. Okay, if I want to see what is in my raster, I can just do something called gdal info, look at it, and it tells you what kind of file it is, how big the file is, what the projection is with all this different stuff. So if you'll notice here, somewhere down here, you're going to end up with the projection for this particular map. Well, you can see all these different, so there's the projection of the ellipsoid, projection of all sorts of things. Okay, let me see where UTM zone, it'll say UTM, there it is, UTM zone 10 north. If I gdal info the TIFF beforehand, it's going to give me a slightly different zone. So the TIFF here has a different projection. So this, if I scroll down, I'm not going to get the same UTM. It's a slightly simpler projection. Okay, now that we have this, we can just look at it. I'm just gonna, what I'm going to do is I am going to write a hillshade. I won't go into how to do this, but I'm calling a lsdtopotools. Oh, I didn't get lsdvistools installed. Make sure that's going. Oh, well, that's not a great start. Okay. Okay, I'm not sure why that didn't work before, but here we go. I'm reinstalling it. Okay. Okay, and then the next step is just plotting the information. So I'm just copying across some plots here. So these are, again, getting copied from the debugging gdal notebook. And there you go. There's your site in Washington State that I just downloaded. Now, so the next part is Scottish LiDAR. It just goes through almost exactly the same procedure as before. I'm not going to do it live here on this recording because the Scottish LiDAR tiles are very large. They're hundreds of megabytes. So, but if we just go to Scottish LiDAR, you can move about, change the location. So in this case, maybe click on Aaron somewhere. If you click on it, you can download that data. That'll be several hundred megabytes. And then once you get it in, you end up with the same process of converting the raster using gdal warp. So this is another notebook which I've done all this already. So you gdal warp the thing. I've downloaded this DEM from the Scottish, or it's a DTM, so trees and buildings off. This is from the Scottish LiDAR dataset. In this case, that is a 1 meter DEM, which ends up to be a very large file size. So you can change the pixel size. In this case, I'm changing it to 3 meters by 3 meters. Again, making sure it's an NV out file, using the using a new file name. And finally, I'm using zone 30 here because the UK, in that part of the UK, it's zone 30. So if you haven't pointed it to the correct proj database, this will break because there's some, there's a little bit of slightly different ellipsoids that the Scottish government LiDAR has. So if there's no access to the proper proj database, this will not work. So again, just like at the beginning of the video, you need to make sure if you're using this to find where the proj database is and set that location as this environment variable. So that's really a key step. If you don't do that, you're going to get errors here. Finally, I just go through the same steps that I did a bit ago. You can copy and paste that stuff. You just need to make sure you've changed the file name so that you use the file name you just wrote. So here I've done everything the same as before, but I changed the file name and then I end up capturing this. So that is what that little piece of Aaron looks like. Right, so hopefully this is useful, and you can make sure that your proj database works, and you can use gdal to manipulate data that you have downloaded.